I added 4 quarters, two quarters on each side, slotted in between the two rows with tape. So that adds more aerodynamic interference, but there's a lot more mass. Let's see. And I took out some of the cross ties because they were the tubing didn't want to conform to them, and it was making the tubing kinked. So I don't know, I didn't mark it exactly how far it got to, but I don't think that helped too much. 8 dimes test. They got pretty high. Let's try again. You are definitely aerodynamic. 6 dimes test. The more dimes, the harder it is for the tape to hold. Yeah, it got pretty high. I think we're getting towards it. 6 or 8 dimes is going to be the answer, but I got to secure them. 2 pennies, front heavy, less weight, aerodynamic. No, it wants more mass. Aerodynamic test with 4 dimes. That actually got pretty high. Let's try that again. I think they got up to here. To summarize, how many factors are militating against me over here? So we have, I mentioned the length of this pullout or trough, whatever you want to call it. I don't think in and of itself just the horizontal distance is the problem. The friction and drag over that distance, maybe. I think the greater issues are first of all, what I didn't mention yesterday was the fact that these feet are not planted firmly. There's a lot of flexibility in the plastic. The more flexibility there is, the more energy can be released. I'm not sure if you can pick up exactly what's happening here, but I can't really see movement, but it is probably flexing as I do it. Then you also have there's a bunch of points of contact. Let me take it off the rails. Before I do that, let me show you this point of contact here as well. I made sure I had cross ties between very close to the join, because before the wheel bogies were hitting the join. There's one thing. I feel it's catching a little bit over there. Right. Well, let me take the train off the track so you can see. I just heard a nut come off somewhere. I have to find it later. Okay. So we have a bunch of points of contact that are adding to friction. So each set of wheels if not for the plastic main axle, there's the bearings are very good, have very little friction. But every time the train has to go yaw or pitch, that's plastic on plastic. Now there's tolerance for it to move, but I don't over the whole horizontal distance, and this twist especially, that's full extension, utilizing all the different axes of rotation here. So again, there's this ball joint in the front, ball joint between the two cars, because each axle has to be 3 degrees of rotation independent of the other ones. And then again, each wheel bogie has to be pitch free on the axles. The one way of overcoming that is to get a bearing, like use bearings as that on the axle, um, or I don't know if the horizontal, these vertical axles are the problems. Could be, but the way I would know is if we had a straight spike here and dropped it from the same height, would it make it throughout the loop? I'm guessing it would. Right now we're getting to here. So we have all the points of contact in the train. What I plan to take off this piece, take off this seat, so that I'm only running one car, so I only have one ball joint. And I can add 6 dimes to this thing, and see how far that would get. I would predict, ballpark, I would get to there. I don't know my physics, so I don't know. And I mean, I don't. Again, I get with a flex question, I don't see the feet moving. But one way to solve part of the flex is to get, like, not silly putty, get what do you call it? Play-Doh type of thing, and stick the feet to something. I don't know if the cardboard would be a good surface for that. And then again, you have the brackets between the track. I think these are called rail connectors. And then you don't want to have constant small intervals between. Realistically, you would have small intervals between. The length of track on a real life roller coaster, the length of track between two cross ties is very, very similar, or less than the width of the cross tie itself. But on my model, I want to have at least the least amount of kinks in my tubing, because it is very weird. So those are the issues that I can see affecting. But I might try this or that with it. Like I said, I might try the Play-Doh. I'll try to decouple these 2 cars. You need to have 2 axles to run. There's no way to run with only 1 axle unless you fix it. If you have one axle, if you just basically run, if I run just the front axle down the track, and I have to somehow put weight on it, I don't even know how I would do that. That could theoretically do it, but then it's just really awkward. It's kind of stupid if he's still point, because I want to have a car going down the track. This is getting long, so we'll cut it here. I haven't really tested anything, but I wanted to discuss my theories and findings and plans. Thanks. 6 dimes test, 1 car. That means less friction on the ball joints, disproportionately more mass. But let's see how that runs. When I did it with off camera, it went less than the 2 cars. Let's try it again, try to catch that. It looks like about there, about the same. But it looks like I'm going to try to print a 3rd car and get 2 or 3/4 per car, 3 dimes per car, and see if that helps. I'm predicting it will, based off of this experiment.